Everyone, my name is Sheena, and today I'll be presenting a foundational data structure in computer science, which is hash table in C++. And we will explore what is hash tables and their real world significance and the limitation. Just a second. Yeah, what all limitations and the direct access tables and how collision are handled using linear and quadratic probing. So let's begin. What is hash table? Why it's important? So a hash table is a data structure that stores key values pairs using a hash function to map keys to an index in an array. So the goal is to access the elements fastly, like typically big O1, and the average time for insertion and search. So let's see the example here. I have the code in my Sublime editor. So it's a hash function and we are passing the two argument, which is key and the table size. And here we are returning the key divided by table size. So whatever the value we will get as a reminder, we will return that value. So yeah. So for example, if we insert the key 27 into a table of size 10, the hash function returns 27 modulo 10 equals to 7. So the key will be stored at index 7 is the array. So why hash tables are important? So because of database um, that uses them for the indexing, and the web browsers which use them for caching, and the compiler which use them for symbol tables. And we have application like dictionaries which store the word dictionary pairs. Let's start with the direct access table. So here, a direct access table store data by using the key directly as the index in an array. So for example, if we have key equals to 50 and we store this 50 in an array. So limitation of that is we need large memory if keys are spreaded. And for example, if the key is 999, you would need an array of size 10 million. So which work only with integer key. So not practical for non-continuous or string keys. So coming to the hash tables, which overcome this limitation by compressing large key spaces into a smaller array using a hash function. And collision and probing techniques. A collision happens when two different keys hash to the same index. So for example, key 27 and 37 both give 7 for key percentile 10. So we resolve this using probing, which searches for another empty slot. Let's start with the linear probing. So in linear probing, if a slot is occupied, we move to the next one in sequence until we find a free space. So I have an example for the linear probing. So we have insert linear function here and we are passing the table and the key as argument here, and we are assigning these um, calculation to the index, which is key percentile table index. So whatever the values that we are getting with this calculation, we are passing it to the index, and we have while function over here which is not equals to -1. So this is returning the key value over here. Let's start with the quadratic probing. So to avoid clustering, we use quadratic probing if it skips indices in quadratic steps. So I have an example for quadratic probing. So here in this code, we are passing three arguments, which is table, key, and the table size. And in index, we are using the same formula, which is key percentile table index. And here we are assigning the 1 to the index value, and we are using the while loop. So hash table, in short, hash table gives us a fast access and efficient memory uses. And the direct access table are only suitable when key range are small and known. And the collision are invitable, and we use probing to resolve them, either linear or quadratic. And the hash table are core to many real world systems, from coaches and database to compilers and the blockchain. So yeah, I have covered all the points. Thank you so much.